Air travel is one of the safest modes of transportation today. The odds of a fatal airplane accident are far lower than those of automobile travel. This safety record is due to rigorous regulations, cutting-edge technology, and continuous improvement. Aviation accidents are complex, often resulting from multiple factors. These can include human error, mechanical failures, and adverse weather. Understanding these factors helps develop effective safety measures.
Fatigue and stress impair cognitive function and increase error likelihood. Pilots face long hours and sleep disruptions affecting performance. Measures like duty hour limitations and rest periods mitigate these risks. Continuous training and proficiency are essential in aviation. Recurrent training programs reinforce skills and introduce new procedures. This commitment to excellence minimizes human error risks.
Modern aircraft are engineering marvels designed for safety and reliability. Rigorous design, manufacturing, and maintenance ensure high standards. Regulatory frameworks and industry commitment contribute to aviation's safety record. Metal fatigue is a significant threat to aircraft integrity. Maintenance technicians use non-destructive testing to detect early cracks. Stricter inspection protocols and improved materials mitigate these risks. Engine failures, though rare, can have catastrophic consequences. Rigorous maintenance checks and pilot training minimize these risks. Modern aircraft are designed to fly safely on one engine. Redundancy and fail-safe systems are fundamental in aircraft design. Multiple independent systems ensure continued safe operation. These principles enhance aviation safety.
Weather significantly impacts flight operations. Pilots must understand and respect atmospheric conditions. Advanced forecasting tools and safety protocols mitigate weather-related risks. Among the many weather phenomena that pose a threat to aviation, thunderstorms stand out as particularly formidable adversaries. These towering behemoths of the atmosphere, often reaching heights of up to 60,000 feet, are characterized by their intense updrafts and downdrafts, heavy precipitation, lightning, and hail. For aircraft, encountering a thunderstorm can be a harrowing experience. The powerful updrafts and downdrafts can toss an aircraft around like a leaf in a tornado, subjecting it to extreme turbulence that can exceed the structural limits of the airframe. Hail, often the size of golf balls or even baseballs, can cause significant damage to an aircraft's exterior, potentially shattering windshields, denting fuselage panels, or even disabling engines. Lightning strikes, while not always catastrophic, can interfere with electronic systems, potentially disrupting navigation and communication equipment. Due to the severe hazards associated with thunderstorms, pilots go to great lengths to avoid flying through or even near these meteorological monsters. Advanced weather radar systems, both on board aircraft and at ground-based weather stations, provide pilots with real-time information about the location and intensity of thunderstorms, allowing them to alter their course to steer clear of these dangerous storms. While thunderstorms may be the most visually dramatic weather threat to aviation, icing conditions present a more insidious and potentially deadly hazard. When an aircraft encounters supercooled water droplets in the atmosphere, these droplets can freeze upon contact with the cold surfaces of the aircraft, forming a layer of ice that disrupts airflow, increases drag, and reduces lift. Even a thin layer of ice can significantly degrade an aircraft's performance, affecting its ability to maintain altitude, control airspeed, and maneuver effectively. As ice accumulates on the wings, it disrupts the smooth flow of air over the wing's surface, reducing lift and increasing drag, potentially leading to a stall. Ice can also build up on other critical surfaces, such as the tail, propellers, or engine inlets, further compromising the aircraft's handling characteristics. In extreme cases, ice accumulation can become so severe that it renders an aircraft uncontrollable, leading to a loss of control and a potential crash. To combat the threat of icing, aircraft are equipped with various anti-icing and de-icing systems. Anti-icing systems, such as heated leading edges on the wings and tail, prevent ice from forming in the first place. De-icing systems, such as inflatable boots on the wings and tail, remove ice that has already accumulated. Pilots also rely on weather information and forecasts to avoid flying through known or forecast icing conditions whenever possible. Section 4. Advancements in weather forecasting and detection enhancing flight safety. In the early days of aviation, pilots often relied on little more than their own observations and rudimentary weather reports to assess atmospheric conditions. However, as aviation technology has advanced, so too have the tools and techniques available for forecasting and detecting weather hazards, significantly enhancing flight safety. Modern weather forecasting models, powered by sophisticated computer algorithms and vast amounts of data from satellites, weather balloons, and ground-based sensors, provide increasingly accurate predictions of weather patterns, including wind speed and direction, temperature, precipitation, and visibility. Onboard weather radar systems, now standard equipment on most commercial aircraft, give pilots a real-time view of precipitation patterns and potential storm cells, allowing them to navigate around areas of heavy rain, snow, or hail. Lightning detectors provide early warning of lightning strikes, enabling pilots to take evasive action or adjust their course to minimize the risk of a strike. These advancements in weather forecasting and detection have been instrumental in reducing the number of weather-related aviation accidents. By providing pilots and air traffic controllers with more accurate and timely information about atmospheric conditions, these technologies have made it possible to avoid many of the hazards that once posed significant risks to flight safety. As technology continues to advance, we can expect even more sophisticated tools and techniques to emerge, further enhancing our ability to predict and mitigate the challenges posed by the ever-changing skies.
Bird strikes and their impact on aviation. Aviation remains intertwined with the natural world. Bird strikes occur when birds collide with aircraft, often during takeoff or landing. These collisions can have significant consequences for aviation safety. Birds can inflict substantial damage to aircraft, particularly to engines, windshields, or wings. The Miracle on the Hudson incident in 2009 highlighted the devastating potential of bird strikes. Captain Sully's skilled actions saved all 155 people on board. The event underscored the importance of mitigating bird strike hazards. Section 2. Mitigating the risk bird control measures at airports. Recognizing the inherent risks posed by bird strikes, airports worldwide have implemented a wide range of measures to deter birds from congregating near runways and flight paths. These bird control programs, often overseen by dedicated wildlife biologists and airport operations personnel, employ a multifaceted approach that combines habitat modification, harassment techniques, and, in some cases, population control methods. Habitat modification focuses on making the airport environment less attractive to birds. This can involve eliminating potential food sources, such as insects and rodents, by keeping grassy areas trimmed short and removing standing water. Modifying the landscape to reduce nesting sites, such as trimming trees and shrubs, can also discourage birds from establishing a presence near runways. Harassment techniques aim to scare birds away from the airport environment. These methods can range from relatively simple approaches, such as using loud noises or flashing lights, to more sophisticated techniques, such as deploying trained falcons or other birds of prey to deter smaller birds from congregating. In some cases, when bird populations reach levels that pose a significant threat to aviation safety, airports may resort to population control measures, such as trapping and relocating birds, or in more extreme cases, culling populations. These decisions are not taken lightly and are typically made in consultation with wildlife management authorities, and with a focus on minimizing the impact on bird populations while prioritizing aviation safety. While bird strikes are well known, foreign object debris, or FOD, is another significant threat to aircraft safety. FAOD includes any object not meant to be on the runway, with serious consequences for aircraft. Even small objects can cause significant damage when ingested by a jet engine. Airports implement rigorous procedures to maintain clean and safe runway environments. Specialized equipment like runway sweepers and vacuum trucks are used to remove debris. The collective efforts of airport personnel, pilots, and ground crews are essential for minimizing FOD risks.
Advancements in technology bring new challenges. Aviation connects people, but is a target for harm. Sabotage threatens air travel safety. Motives range from extremism to terrorism. Consequences include loss of life and economic disruption. History shows aviation's vulnerability to sabotage. Pan Am Flight 103 and 9/11 highlight this threat. These events led to major security changes. Balancing efficiency and security is crucial. Section 2. The human element. Vulnerability and vigilance in aviation security. In the intricate and interconnected world of aviation security, where technology plays a crucial role in screening passengers, luggage, and cargo for potential threats, the human element remains both a strength and a vulnerability. While advanced imaging systems, explosive detection devices, and sophisticated databases help to identify potential risks, the effectiveness of these technological tools ultimately depends on the vigilance, training, and judgment of the individuals operating them. Security personnel, from airport screeners to baggage handlers to air traffic controllers, serve as the front line of defense against acts of sabotage. Their ability to recognize suspicious behavior, identify potential security breaches, and respond effectively to evolving threats is essential for maintaining the integrity of the aviation system. However, the human element in aviation security is not without its vulnerabilities. Fatigue, complacency, and human error can all undermine even the most well-designed security protocols. Moreover, the sheer volume of passengers and cargo passing through airports each day presents a daunting challenge for security personnel tasked with identifying potential threats amidst a sea of benign travelers and goods. To mitigate these vulnerabilities, the aviation industry invests heavily in training programs, background checks, and ongoing evaluations to ensure that security personnel possess the skills, knowledge, and judgment to effectively carry out their duties. These programs focus not only on technical proficiency with security equipment, but also on developing situational awareness, critical thinking skills, and the ability to recognize and respond to suspicious behavior or potential security breaches. Section 3. A layered approach, strengthening defenses against malicious acts. In the face of evolving threats, a single line of defense is no longer sufficient. The aviation industry uses a layered approach, combining physical, technological, and procedural measures. This strategy creates interconnected safeguards, making it difficult to exploit vulnerabilities. Physical security measures at airports include perimeter fences, checkpoints, and surveillance. Technological advancements like X-ray machines and biometric systems enhance security. Procedural measures such as background checks and security training are crucial.
The unending pursuit of safer skies. The quest to prevent airplane crashes is a multifaceted and perpetually evolving endeavor. It's a testament to human ingenuity and relentless innovation. The aviation industry's relentless pursuit of safer skies has yielded remarkable results. From the earliest days of powered flight to modern aviation, the journey has been marked by both triumph and tragedy. Each incident has provided invaluable lessons, leading to refinements in aircraft design and safety regulations. Air travel today is safer than it has ever been. Section 2. The future of aviation, safety, innovation, collaboration, and a culture of excellence. As aviation technology continues its relentless advance, the future of air travel holds both exciting possibilities and new challenges for ensuring safety. The rise of autonomous flight systems, The development of novel aircraft designs and the increasing integration of artificial intelligence into air traffic management all present opportunities for further reducing the risk of accidents. However, these technological advancements also raise new questions about human-machine interaction, the potential for software vulnerabilities, and the need for robust cybersecurity measures to prevent malicious interference with increasingly automated systems. Addressing these emerging challenges will require a collaborative effort among aircraft manufacturers, airlines, regulators, research institutions, and technology companies. Sharing data, best practices, and lessons learned from both accidents and near misses will be crucial for staying ahead of potential safety threats and ensuring that technological advancements translate into tangible improvements in safety. Ultimately, the most critical factor in the ongoing quest for safer skies is the cultivation of a robust safety culture within the aviation industry and among all those who participate in the miracle of flight. This culture, deeply ingrained in every aspect of aviation operations, must prioritize safety above all else, encourage open communication and reporting of potential hazards, and foster a relentless pursuit of excellence in every task, no matter how small. By embracing these principles, the aviation industry can continue its remarkable journey towards ever safer skies, ensuring that the dream of flight remains a source of wonder, connection, and progress for generations to come.